Let me introduce myself. Myself is Kaushal Parikh, Dr. Kaushal Parikh. Right now, today, acting as a principal of this particular institute, Government Engineering College, Dahod. Uh, this Government Engineering College, which has been established in 2004 with the 5 effective branches: civil, mechanical, electrical, EC, and computer, and the 2 PG branches, which has been established in 2010, specifically in civil structure engineering and mechanical in CAD/CAM. So it is our great pleasure for us that you are sharing your expertise specifically for the foundation, geotechnics, and modeling as far as the FEM is concerned. Our college and our students, right now we have invited 190 students approximately, and if I will see right now over here, then approximately 70 students which has been joined right now. So expecting the more students can join over here and take the advantage of your knowledge. So Hamza sir is a technical manager of SA Amrocol CST oil and gas projects. He is a design engineer. Specifically, he is more involved as a poet, as a lecturer and reviewer also. So in spite of his busy schedule, they have given their consent over here. They have given their valuable time over here to share their views, share their expertise over here. So on the behalf of the students, Government Engineering College, Dahod, I warmly welcome you uh, in this particular session. Thank you.
Thank you, sirs, giving the welcome speech to our Hamza sirs. I request to Shivani give the brief introductions about the our Hamza Al Hasimi sir. Shivani, please. Hello, Shivani. Shivani.
Yes, sir.
Yes, please continue.
Am I audible, sir?
Yes, yes, you are audible, please.
Okay.
Has been established in 2004 with the 5 effective branches: civil, mechanical, electrical, EC, and computer, and the 2 PG branches which has been established in 2010, specifically in civil structure engineering and mechanical in CAD/CAM. So it is our great pleasure for us that you are sharing your expertise specifically for the foundation, geotechnics, and modeling as far as the FEM is concerned. Our college and our students, right now we have invited 190 students approximately, and if I will see right now over here, then approximately 70 students which has been joined right now. So expecting the more students can join over here and take the advantage of your knowledge. So Hamza sir is a technical manager of SA Amrocol CST oil and gas projects. He is a design engineer. Specifically, he is more involved as a poet, as a lecturer and reviewer also. So in spite of his busy schedule, they have given their consent over here. They have given their valuable time over here to share their views, share their expertise over here. So on the behalf of the students, Government Engineering College, Dahod, I warmly welcome you uh, in this particular session. Thank you.
Thank you, sirs, giving the welcome speech to our Hamza sirs. I request to Shivani give the brief introductions about the our Hamza Al Hasimi sir. Shivani, please. Hello, Shivani. Shivani?
Yes, sir.
Yes, please continue.
Am I audible, sir?
Yes, yes, you are audible, please.
Okay. So now I would like to invite Hamza sir, who is an engineer. He is result oriented and an inspired technical manager at senior geotechnical design engineer. He is a poet, lecturer, and a reviewer and MSc holder, who has a research more than of 8 years of his experience in SA, Aramco, CSD oil and gas project, shoring slopes, piles, micropiles, pile draft, ground improvement, etc. In 2012, he gained his BSc with honor in civil engineering from UOFK. In 2018, he completed his MSc program with honor in geotechnical engineering. His work and publication works on unsaturated soils, mechanics, granules, materials, behavior, slope, stabilities, foundation design, DEM, MPM, FEM, SSI, piles, raft, post-tension drafts, micropiles, reclamation, Pelix 3D, and molecular nanosimulation in geotechnical and geoenvironmental applications.
So
He is a technical manager at Strong Force MGWL from December 2019. He is a senior geotechnical engineer from September 2018 to December 2021. He is a part-time lecturer. He has done a part-time lecturership in University of Bahrain for 2 years. He have also worked as a senior geotechnical engineer for 1 year and 10 months from October 2016 to July 2018 in Saudi Arabia.
okay. So we welcome you, sir. So now session is yours, sir. Please, sir, share your experience. I from the GIC club coordinator. Welcome you, sir. Hello, sir.
Thank
Please.
you. Thank you everyone for the guests and the organizers and the students as well and the whole GIC community. Am I audible to you guys or?
Yes, sir. Yes, sir. Yes, you are audible, sir. Completely.
All right. Thank you for your nice introduction, and hopefully today we will discuss about the foundation geotechnics, 3D finite element modeling with the new trends, hints, and practical aspects. I have seen already some of the students' questions, mainly doubting or concerning about what is foundation geotechnics are about. Actually, foundation geotechnics are the part of geotechnical engineering which relate to the foundation field in terms of analysis, design, and construction, as we will come to see in this webinar. The outlines of our webinar will be an introduction to our topic and then followed by an overview of the topic, and then we will discuss about the raft foundation in general, what are the advantages of the raft foundation and when we can adopt raft foundations over other type of foundations. Then we will move to the piles and the new trends and the new type of foundation. Then finally we will discuss a case study before we move to a career path and advices to the students and the junior geotechnical engineers, or for those guys who want to develop their career in geotechnics. Finally, we will have Q&A sessions. So as an introduction, foundation engineering can be divided into two parts or two stages. First, the design stage, which unfortunately many of us confusing it or mixing it with the other stage, which we will discuss in a minute. But the most important thing to know is that you have to always start with the analysis stage. Some people or some of the engineers usually start reversely from the design phase ignoring the analysis phase. But it is important to remember and understand that finite element softwares, different design analysis methods like the limit equilibrium, the material point method, the discrete element modeling, using any of the available softwares, the free or commercial like Plaxis, Abacus, or Midas, or any other softwares, those are all till today are only analysis tools. You cannot use it for design. So as a geotechnical or foundation engineer or a geotechnical designer, you have to use those tools to analyze the problem, the foundation problem you have, and then based on the outputs of those analyses, you have to use the design codes available in your country or in your state, or as requested by the owner or by the client or consultant, etc. So there are different items or teams working in foundation engineering field. You may be one of those fields, and remember, it is always a collaborative effort or teamwork that has to be there to ensure systematic and safe and reliable foundation engineering solution. It starts absolutely with the owner, representative, or the consultant engineer, then the geotechnical or site investigation engineer, the structural design engineer, and the geotechnical design engineer. And there are certain interactions and communications should occur between all of those entities before designing or decide the final foundation solution. After all of those entities agreed upon the final foundation design, then only they gain the approvals and they will pass the information to the construction team to start constructing this foundation solution on site. Unfortunately, as we will see over and over this webinar, most of the time, the geotechnical part and foundation engineering by many of practicing engineers, they think it is limited on the geotechnical site investigation part. Most of the time, the geotechnical design engineer or the geotechnical design engineering phase is being ignored in many of the projects, which might lead to enormous errors and mistakes and dangerous in terms of foundation engineering. So we have an overview. We will discuss about the shallow and deep foundations, as many of you are aware, I believe, and then the flexible versus rigid foundations and the advantage of the 2D versus 3D finite element or analysis tools. So the shallow foundation, by definitions, they have to satisfy that the depth of foundation over the width of the foundation has to be less or equal to 1. While the deep foundation violates this assumption, then the shallow foundation transfers the loads horizontally, while the deep foundation mainly transfers the load vertically down to a competent or more competent strata. And we have the shallow foundation are mainly depending on the end bearing capacity of the soil, while the deep foundation might be a combination of the two. The shallow foundation is usually cheaper. In most of the cases, I would say 95% of the cases, the shallow foundation are cheaper option. Therefore, you have to always start thinking about shallow foundation. Unfortunately, as a practicing engineer, I have been in the field for 8 years, and I have crossed many times where many of the geotechnical reports or soil investigation reports have straight away recommended deep foundation as the foundation solution, where in most of those cases, it was a case of over design. So they didn't really need a deep foundation and they could suffice with shallow foundation, but it has to be analyzed by a geotechnical designer, which was not the case. And this emphasized the importance of geotechnical design engineer or foundation geotechnics. As an advantage also for the shallow foundation compared to the deep foundation, it doesn't require special skills. Most of the contractors, workmanships or laborers, they are well educated and well trained to do the shallow foundation works, unlike the deep foundation, which requires experience on certain equipment and machineries. It can work well, but to an extent, the shallow foundation, where if we exceeded the allowable or permissible limits for the settlement, either differential settlement or total settlement, or the allowable bearing capacity, or we have significant lateral loads and overturning issue, then we have to move to the deep foundation. But again, before moving to the deep foundation, you have to analyze the problem and make sure that shallow foundation will not work, and the only option will be the deep foundation. As we said, always start from shallow to deep. Don't start with deep foundation or jump or ignore the shallow foundation as an option for your foundation system. We have another assumption we usually make as design engineers or analysis engineers when it comes to the foundation engineering. We assume most of the time that the foundation are either flexible or rigid, based on the so-called theory that Winkler springs, one of the most famous theories for structural engineers who deal with foundation. And unfortunately, it is not the ideal representation of the soil to be dealt with, but this is the understandable part of soil mechanics to our friends, structural engineers. But we will see what are the limitations and the shortcomings of those assumptions and theories. For example, based on the ACI code 336, we have a rigidity factor, Kr, and there are many equations for the rigidity factor. This is one of them, how to define the rigidity of the foundation system. It depends absolutely on the soil, on the structure, and on the geometry of the foundation. For example, for this ACI equation, if the Kr was greater or equal to 0.5, we assume the foundation is completely rigid and the differential settlement is almost zero, that we don't have a differential settlement and the whole foundation will settle or will deform as one entity. If it is less than 0.5, it will be a pure flexible foundation, and the differential settlement will be approximately 35 to 50% of the total settlement. But this is not always the case, and it is not accurate representation of the soil or of the foundation behavior, because to be honest, the foundations are neither 100% flexible nor 100% rigid. It will behave something in between, and we have to analyze it something in between. And most, if not all, of the available equations and conventional methods, they fail to consider this fact. They will assume it either completely rigid or completely flexible, which is another shortcoming of those conventional methods. What will be the solution? The solution will be to use a tool, analysis tool, that is capable to model or capture the actual behavior of the foundation system, like the finite element modeling. Why we in this webinar we are focusing on the 3D, and what are the advantages of the 3D analysis or 3D finite element compared to 2D finite element in foundation engineering. I always bring this simple finite element model we have developed for a raft foundation and retaining wall for a villa. It is a small project, yet we have used Plaxis 3D for it. And actually 3D models can be used in nowadays on daily basis and on each and every project despite the scale or the size of the project. So if you can notice here in this project, we have two different levels for the raft foundation. We have different loads, irregular loads, non-uniform distribution of the columns. And we have retaining wall, we have interaction between the soil, the retaining wall, and the two level of the rafts. We have differential settlement. So all of those complicated behavior cannot be represented by a 2D plane or a 2D space. The loads, as you can see, or as we said, it is non-uniform load, irregular load distribution, not a uniformly distributed load, UDL. The geometry itself is unsymmetrical and there is no axis of symmetry nor plane strain condition. So most of the time in geotechnical reports or when we are using 2D finite element, we are forced to assume that the foundation is either symmetric or in a plane strain condition, and neither of those applied here. So this means that neither the conventional raft or foundation equations or design methods are applicable, nor the 2D are applicable. So we are forced in such kind of situations to use the 3D finite element, and this is the power of 3D finite element. And as we mentioned, that the soil structure interaction, the SSI, between the different elements involved in this model, which are the soil, the groundwater table, the loads, the columns, the retaining walls, the different part of the rafts, all of these complicated the scenario and making the 3D analysis essential. Of course, if we want to add in all of these interactions, a time-dependent behavior like creep and long-term effects, we have to think about advanced 3D modeling and analysis tools. But always remember that don't let this fool you of 3D or finite element is not a magical tool. If you put trash in, you will get trash out. And always think about calibration. You have to calibrate the 3D analysis or 3D finite element models before using it for your final design. And we will see over this webinar how you can estimate the initial parameters in your finite element analysis and what tools you will need to calibrate those models easily with less efforts and cost. Moving to the raft foundation as a part of the shallow foundation, which we will focus on in this webinar. Actually, the raft foundation distribute the contact pressure over large area compared to the footings or the isolated or combined footings or strip footings even. So the main advantage of the raft foundation, they reduce the contact pressure because they are redistributing the force over a larger area. And by this, we are reducing the settlement or the foundation deformation. One of the main advantage of the raft foundation is the bridging. If you have a spatially heterogeneous or anisotropic ground where part of the ground is weak and part of the ground is stiff or strong or hard, the advantage of the raft foundation, it will provide you with less differential settlement compared to any other system, especially the isolated footings. Usually the soil bearing capacity in the raft foundation, and this is one of the main points we have to consider, and unfortunately in 90% or 99% of the soil reports and geotechnical investigation reports, they fail to address this point. The soil bearing capacity of raft foundation is most of the time controlled by the total and differential settlement, not by the shear failure. And here, why they are different from the isolated footings, because isolated footings, they are controlled more by the shear failure, either bunching shear or general shear or other type of shear failure. But in raft or mat foundation in particular, they are limited to total and differential settlement rather than the shear failure. The overburden must be considered, of course, on the raft foundation, and the raft foundation, just like slabs or inverted slabs, they can be flat foundation or raft with beams or raft with drop panels or raft with upstands. and any other type of raft foundation. Now, this is as a part of shallow foundation, we have the raft foundation. As a part of deep foundations, we have piles. And from size perspective, we have the bored piles, which they have diameter larger than 300 millimeters. And when they have less than 300 millimeter diameter, we call them micro piles. And they have different types. Both of those bored piles and micro piles, they have different types based on the shape, based on the method of installation or grouting. And each of them, they have advantages and disadvantages. From installation point of view, we have bored piles or driven piles or CFA and other type of foundations, of deep foundations. Based on the shape as well, we have different type of piles or deep foundation, like circular piles, square piles, under-reamed, and we even have recently X-shaped piles developed in China. We have skin friction based on load transfer mechanism. We have skin friction piles, end-bearing piles, or combination of the both. And we have certain special topics or consideration we have to focus on when we are dealing with deep foundation, like the negative skin friction, the liquefaction, the swelling, the tension in the piles, the group effects, and the creep. And unfortunately, in many cases, those topics or considerations have been ignored in the design. And we will see cases where that even piles foundation could fail and lead to a catastrophic failure in foundation system. And one more important note to consider, that the pile capacity is not guaranteed when you are calculating the pile capacity, whether the end bearing or the skin friction capacity of the piles from the different literature or different design equations or correlations. You have to understand that those are not guaranteed capacity. The capacity of the piles, whether the end bearing or the skin friction part, are associated with the amount of settlement or deformation the piles will undergo. So if the piles didn't settle by this amount, it will not develop the 100% of that assumed capacity. It has to settle by a certain amount, depend on the type of the soil and depend on the type of the loading. If they settle for that particular amount of settlement, they will not develop the 100% of their capacity. That's why the load settlement curve of the pile and the load settlement behavior of the pile are of crucial importance for all geotechnical engineer, and they should understand and develop those curves before they draw any conclusion on their foundation design. The settlement of piles, it has to be considered because I think most or a lot of people, they think that piles or deep foundation will not settle, or they have the least amount of settlement, which is of course not true, as we will see in one of the case studies in a minute. The settlement of the piles comprises from friction or shaft settlement or deformation, end bearing or base deformation, and elastic deformation, which is the material deformation itself. And remember, even in rock, piles do settle because rock are not incompressible. And we can estimate the pile settlement or the load settlement curve from calibrated finite element model, which are less expensive than pile load test for sure. And in the ideal situation, you will need a combination from the two, the calibrated finite element modeling results and pile load test results. As a new trend in the foundation, we have something called piled raft or combined piled raft foundation, CPRF. And I'm not sure if all of you have heard about this type of foundation, but we have situations where we need something better than a shallow foundation, which is raft foundation, but we need something less than completely deep foundation. So we have something in between called combined piled raft analysis. It is a relatively new technology developed in Germany. It is usually used for high-rise and skyscraper buildings. It can be piled reinforced concrete raft or piled post-tensioned raft, micro-piled RC raft, or micro-piled post-tensioned raft. The piles itself and the system can be connected to the raft or unconnected to the raft, depending on the situation, or it varies from case to case and from project to project. Usually the loads of the superstructure are shared between the raft and the piles, and in most of the cases the loads on the piles usually carry 60 to 85% of the superstructure loads, and the actual load sharing capacity will depend. This is actually an output, not an input. The load sharing percentage, the 60 to 85%, you will assume it in the beginning, but ultimately you have to determine it using advanced 3D finite element analysis. Professor Bolus has pioneered the CBRF analysis methods, and he has bought many theories and manual solutions for the combined piled raft foundation, as we will see in a minute. We have mainly 3 cases for the CBRF, or the combined piled raft foundation system. We have the first case where the piles will be mainly used as a settlement reducers, only to reduce the settlement where we have a good ground and the raft foundation capacity is sufficient to carry the load, but we have an excessive settlement problem. In such cases, we are using the piles foundation only to reduce the settlement. And the advantage of this case, or this type of foundation, that we can allow the piles to carry up to 100% of their ultimate bearing capacity. So the factor of safety of the piles, we can allow it to reach 1, not 3, not 2.5, but 1. However, the factor of safety of the global system has to be sufficient. We have to determine it and analyze it by different means, like the soil shear strength reduction method, SSR, and other method of factor of safety. The second case, where we use the pile foundation as a stress reducers, where we have exceeded the allowable capacity or allowable contact pressure on the soil. In such cases, we use conventional factor of safety, and the load sharing on the piles will be usually greater than 60%. In case 3, we have using the piles to resist lateral loads, for example, to control the overturning capacity of the building, or to resist winds and seismic load. And those are the ideal cases for CBRF foundation system. But in reality, it will be a combination of those 3 or any 2 cases among those 3 cases. And it is important to notice that if you end up with a load sharing capacity or a load sharing percentage on the piles greater than 85%, or say 90%, then it is viable to move to deep foundations, because the contribution of the raft foundation here is minimal. Of course, it depends on the sophisticated and advanced analysis before reaching to this conclusion. We have certain guidelines. Unfortunately, they are not many, and still there are real needs to develop codes or standards or guidelines for deep or combined piled raft foundation, CBRF. However, there are good enough literature and guidelines developed so far. One among them is the ISSMG, the International Society for Soil Mechanics and Geotechnical Engineering. They developed guidelines for CBRF. Professor Bolus articles and research, and we have Bolus Davis Randolph BDR methodology. However, all of those guidelines and methodologies are general and they have certain assumptions and limitations. Remember always that those analytical solutions are limited. They usually tend to assume uniform bile spacing, the loading to be uniformly distributed load, UDL, and regular raft geometry. But in reality, we could violate one of those assumptions, if not all of them are violated. So there are complications associated with using those analytical solutions in terms of real project and large bile draft foundation system. So in such cases, we again coming back to the soil structure interaction and 3D finite element modeling and analysis. So is it optional? I will leave the answer for you. But remember always the value engineering and the cost effectiveness or cost saving evaluation of the CBRF varies from project to project and has to be evaluated on case by case basis. Because some of the in some cases it might not be the ideal foundation system to be used, and in some cases it will be. So it depends on the value engineering analysis and complicated and advanced 3D analysis before reaching a conclusion to your foundation system. Why we are keep saying that the bile draft or combined bile draft foundation system are complicated due to amount or magnitude of interactions involved in this type of foundation systems. We have in the foundation system itself almost 4 different types of interaction. We have the bile interact with the other biles, we have the bile interact with the soil, and we have the bile interact with the raft, and the raft with the soil, and the load with the whole foundation system, and the time dependency, and many other interaction aspects which really make this foundation system one of the most complicated system to be analyzed, and you have to have advanced tools to analyze such an advanced foundation system. But of course, everything has its own advantage and disadvantage. And in this chart, I just want to show you the distribution or the change or the variation from deep foundation or shallow foundation. On the x-axis here on the chart on the left, we have the alpha BR, which is the load sharing on the piles. If we have a 0 alpha BR, we don't have any piles, and in such cases on y-axis we have the settlement improvement factor as 100%. Or the settlement factor, let's call it in this case 100%, which means that the settlement is equal to the settlement of the raft foundation alone. When we increase this ratio on x-axis, means the piles start attracting more and more loads till we reach 100%. And what we are noticing that the settlement is reducing while we are increasing the load sharing capacity on the piles. On what basis we have to select or adopt the ideal percentage of the load sharing? It depends on the geotechnical designers. What is your allowable settlement? What is the costs budget for the client? And many other factors. So it is advanced system, complicated system, rely on advanced analysis tools and a lot of experience and deep knowledge of both shallow and deep foundation system before reaching the final and optimum foundation design for CBRF. Remember, it is always starting from the basics. in most of the cases, we have only the basic parameters for the soil, because you will start always from the basic soil reports and the soil parameters provided to you, especially in the initial stage. So you have the standard penetration test, the CBT test, and in our region, I'm not sure about India, but in our region, most of the cases we have the SPT, the standard penetration test, and only SPT in the initial stage. But one of the most abused parameters is the SPT and values if it is used incorrectly, especially if the hammer energy correction or hammer energy efficiency certificates are not provided. And in this chart, for example, if you can see, the blue line represent a SPT profile for a certain site done by a certain machine, and the black line represents another machine which has done the SPT on the same soil profile. Both of them has different SPT profile values. But actually, if both of them, for example, the blue line has an energy efficiency of 40% and the black line has energy efficiency of 80%, if both of them consider those hammer energy correction, both of them will yield the same value, which is the red line, the N60 values. Again, unfortunately, most of the people will not do this correction, and it is neither available, the hammer energy certificate or hammer energy efficiency value will not be available in most of the cases, but it is of a crucial importance to use them, because you can end up over designing or even overestimating the safety factor or the strength of the soil, which can be dangerous and could lead to foundation failures. Another of the misused or abused field test, it is the plate load test. Actually, it is one of the mostly used test or field test to verify the bearing capacity. But again, if you don't use it considering the limitations or the assumptions of this field test, you can end up misusing it or abusing the output of these tests. Remember, according to Joseph Bowles, which is a well-known reference in geotechnical or foundation engineering, if the width of the foundation exceeds 6 to 15 times the width of the plate, which mostly the case in raft foundation. In raft foundation, the width of the raft will definitely be more than this ratio, 6 to 15 times the width of the plate. We cannot use the prototype or analytical solution. If we have layered soils or multi-layers of the soil or heterogeneous or anisotropic soils conditions, we cannot use those prototype analytical solution to estimate the bearing capacity or the stiffness of the ground. But can we still use the plate load test after all of these disadvantages or limitations or assumptions? Yes, we can. If carefully adopted, we can actually use it as a cheap option to calibrate the numerical model. In this example, in this chart, you see a plate load test have been simulated in Blacksys 3D for 2 layer of the soil. However, the calibration is done to calibrate or to back calculate the soil constitutive parameters of the first layer. Okay, so in that case, you can use the plate load test results to back calculate or calibrate the soil model parameters, knowing the assumptions and the limitations of the test. And you can see the black dotted line is the estimated or the back calculated load settlement curve from Laxes, and the blue line represent the field test, and both are in good matching. Another crucial hint or parameter in estimating the stiffness of the raft foundation will be the modulus of subgrade reaction, Ks or Kz or whatever you call it. Unfortunately, one of the crimes in foundation geotechnics is to use this equations, which is 120 into the allowable bearing capacity, which will give you the Ks in kilonewton per meter cube. Don't please ever use this equation to design especially raft foundation or to estimate the modulus of subgrade reaction for this foundation. Remember always that Ks is not an intrinsic property of the foundation system. It is not intrinsic property of the soil. It depends on so many variables, such as the type of the soil layers, the heterogeneity and anisotropy of the soil, the groundwater table, the type of the loading, the location of the columns or the loading, magnitude of the loads, foundation's geometry, the center of gravity of the loads and the foundation, and many other aspects. Any change in any of those parameters will lead to change in this modulus of subgrade reaction or Ks value. And remember, it is not a single value. There is nothing called a single value Ks for the whole foundation system, especially for the raft foundation. So how we estimate it? Again, we can estimate it from analyzing or post-processing the output from the 3D finite element modeling. And in most of the cases, we have this Ks acting no more than fitting parameter. It is in most of the cases where we have deep excavation or uplift or consolidation or long-term or short-term problems, this Ks value is meaningless and only act as a fitting parameter to translate the information we have got from the geotechnical or soil structure interaction analysis and to connect it with the structural model. And we have another advanced tools or another advanced method which called coupled analysis, which can couple the structural model with the geotechnical or soil structural interaction model, and this will yield the most accurate behavior of the foundation and the superstructure all in once. Another hint that don't assume that the pile capacity or the pile ultimate bond strength is constant. It varies with depth, even in the same soil layer, depend on the soil profile. And for micropiles especially, it is important to check the buckling capacity or the buckling behavior of the piling or micropiling element. In most of the cases, this also overlooked, and people, they think that piles will not tend to buckle, but there are certain case studies in the literature where they shown that piles or micropiles, they can or they do buckle, actually depend on the section of the or the cross section of the piles or the micropiles and the elastic modulus of the soil. So here in this method, actually you can find it in Federal Highway FHWA guidelines for micropiles. You can find more explanation on this method. The red dot or the red point represent the pile case, where we have a pile factor, depends on the pile cross-section geometry, and we have on y-axis the modulus, the soil modulus or the stiffness modulus of the soil. And if it lies with above this line, most likely the pile will fail under compression, and if it lies below this line, the pile will most likely fail under buckling. Another field test that can be used to calibrate or by a great extent to calibrate the finite element, the 3D finite element tools is the biload test. And here I am showing an example of micro biload test in the purple color, which is the field results. And after the calibration or back calculation and the finite element model, we have obtained this black dotted line, which again in good match with the field results. So in such cases, we are using simple and non-expensive means or tests to calibrate our finite element modeling. So again, we are coming back to this point where we have discussed that some of the engineers think that deep foundation or piles are always over-designed and they will never settled, or at least not to a great extent, but this is not the case. I recommend all of you to go and visit this case study, which is recent in 2020, I believe, where the University of Sheffield in UK have been demolished and the whole site was rebiled due to a piling design error led to significant pile foundation settlement. So yeah, pile settled even in rock because rock is not incompressible material. Another question will be arising in most of the practitioner engineers, like what kind of soil model I have to use. And this is an important question, and it depends on the type of the soil you have and the type of the loading and the type of the problem you are analyzing. You can see here Mohr column, Drucker-Bragger, or the CAB model, or modified CAM clay, or hardening soil model, or hardening soil model with a small strain stiffness. And each one of them is good for certain type of soil and bad for the others. So it is the geotechnical designer choice to select the most appropriate constitutive model. But again, remember that the more advanced model you are adopting, the more parameters you need. And if you don't have those parameters, or you cannot obtain a reliable values for those parameters, don't go for advanced models and use, especially for the initial phase of the design, use suitable and less complicated model, at least that you can have the parameters for those models. If you cannot have a balance between all of this, then don't use finite element at all, because again, rubbish in equal to rubbish out. And the boundary conditions, you have absolutely to estimate a reasonable geometry size for the finite element model, because it is a boundary dependent. You have to make sure it is your results are not affected by the boundary conditions, and this will come with experience and practice on finite element and following certain guidelines published in the literature. Here, for example, I just wanted to highlight that you have to understand each parameter in the soil constitutive model. What does it mean and what impact it can do? For example, in the hardening soil model or hardening soil model with small strain stiffness, the parameter M, which is the power factor, it can vary from 0 to 1. For example, for rock, pure rock or sound rock material, it will be 0, and 0 mean constant soil stiffness modulus. For pure sand material, it will be 0.5, and for pure cohesive clay material will be 1. And you can see the behavior of the soil stiffness value. The stress is altogether different between those parameters. So you have to understand what does each parameter means before you are using this model or this parameter. Another important aspect, if, for example, when dealing with the finite element analysis, to calculate the factor of safety or the safety factor based on the SSR method, the shear strength reduction method. In the blue line, for example, is the analysis result when you consider only the soil shear strength reduction method, which give you more than two actually factor of safety. However, if you include this analysis for this particular chart was done for a sheet pile or anchored sheet pile system. So when we run the analysis or the safety analysis for this system, considering only the soil in the SSR analysis, we will have a factor of safety more than 2. If we include the sheet piles, this factor of safety is reduced to almost 1.9. And if we include the anchors and the whalers, we are further or significantly reducing the factor of safety to 1.4. So it is important to include the elastoplastic behavior of all elements involved in the model, not only the soil. If you have run the safety analysis or the SSR analysis only for the soil, you will end up with overestimated safety factor, and this can be dangerous. Another aspect you have to consider is a barometric study to evaluate the effect of different parameters on your analysis output or results. And as you know, or you should know, that the finite element modeling or method is dependent on the mesh. It is a mesh sensitive method. So the size of the mesh or the number of elements or number of nodes in the mesh do affect the results. If you don't have any field results to compare your output with, your only option will be to do a sensitivity mesh analysis, run a different configuration of the mesh with different coarseness or fineness factors, which will produce more number of elements. And for example, in this particular case, we're interested to know the settlement of the foundation system. And you can see that the asymptote almost reached, or we have reached a balanced or almost constant value, approximately on 70,000 element mesh. So we will pick this type of mesh because this is the most viable mesh to be used. If we adopted this type of mesh or this type of mesh, there is no significant improvement in the analysis results or in the outputs, but the calculation time will be significantly higher with no huge advantage. So this is the suitable or the optimum mesh size. This is one way of adopting the most suitable mesh size for your problem. Another aspect of the barometric study or the barometric analysis to determine the optimum or most suitable number of piles or micropiles and pile draft or CBRF system. This AB is area of the piles divided by the area of the raft, which represents the number of the piles actually. And you can see that in this 1.1% almost give us the asymptote, which represent the most optimum or most appropriate number of piles. This is one way also to determine the optimum number of the piles, because in CBRF system, the combined pile draft foundation system, we have an optimum number of piles. Beyond it, there is no further improvement in the settlement. You just will keep adding piles with no advantage. So we don't want to have this case, and this parametric study is one of the methods to avoid that situation of over design or adding piles where you don't need them. another way of representing the settlement improvement factor and the number of the piles. Again, this is more clear where we have the asymptote with different pile length and different pile diameters, different pile numbers, and we can see where we achieve the asymptote. Now let's move to the case study for a real project we have done in Bahrain. We have actually reclaimed artificial island in Bahrain, and our client wanted to build 3 residential towers. Each of them is approximately 500 square meter with multi-story building, almost 6 or 7 story. But the problem underneath those towers, the proposed foundation system was a raft foundation, and underneath those raft foundation there was a chilling pipeline, a water chilling pipeline passing through those 3 towers. And the authority of the water and electricity, they don't allow to construct anything on top of those pipelines within an area of 1.8 meters. So what we have proposed to them is a cantilever post-tension raft foundation. And the advantage of using post-tension, maybe we can discuss this in another seminar or webinar. The post-tension actually, in short, it helped to reduce the reinforcement in the foundation, and it helped to reduce the thickness of the concrete. So it is faster, cheaper, and has more crack width control. This is the main advantage of post-tensioning techniques in foundation. So we have proposed a raft foundation with portion of this raft foundation cantilevered, the 1.8 meter cantilevered, so we will not transfer any stresses or any loads on the soil. So we will not affect the chilling water pipeline. But in that case, because the cantilever part is carrying columns for the tower, we have an overturning issue for the foundation system, and we have solved this by introducing micropiles. Approximately the average thickness of the raft was 1 meter, and we have proposed 24 micropiles with 250 millimeter diameter of varying length. The ultimate results was a 30% cost saving for the client and 50% time saving, because the micropiles are faster, and the post-tensioning also in the raft make the process of the foundation or casting the foundation also faster. This is the one of the tower layout. We have almost 22.5 meter length and 5.1 meter width with 1.8 meter cantilever, and you can see the column layouts and different thickness of the raft for the main raft and the cantilever portion 800 millimeter, and the distribution of the micropiles along the raft. This is the micropile load test we have done on site, and we have used the results to calibrate or back calculate the soil parameters in the finite on the 3D finite element model. This is the 3D finite element model results, where we have appropriate total and differential settlement. We have almost 10 or 12 millimeter of differential settlement with adequate safety factor and contact soil pressure. This is the output of our spring values for the piles or for the micropiles. Each micropile has different spring value or stiffness, as well as the raft. And we have done a coupled analysis actually between the post-tensioning model or post-tensioning software and the geotechnical or soil structure interaction software. In this case, in the structural software or the structural model, the soil has been represented by a number of or an area spring the soil or of the soil stiffness, but this is not didn't came from the soil reports or didn't came from assumptions. It came from post-processing the 3D soil structural interaction models. We have finished the main part of our webinars. As a career path, as we have shown this in the beginning of our webinar, you can pick and choose any of those engineers involved in foundation engineering. You could be the consultant or the owner representative engineer. You could be the geotechnical investigation engineer. And I assume that all geotechnical engineers in the beginning of their careers, they have to start as geotechnical or site investigation engineers. Then you can work also as a structural design engineer or geotechnical design engineer. And remember, it is always important and crucial to maintain a level of communication and mutual language between all of those engineers and parties in terms or when it comes to foundation engineering. It is always important to have a certain skills and toolkits in your hand if you want to peruse your career in foundation engineering. You have to be familiar with different numerical tools, either 2D and 3D finite elements. There are plenty like Plaxis, Midas, Abacus, ANSYS. The different analysis methods like the limit equilibrium, the material point method, discrete element modeling, and many other models. The main and essential softwares and tools for most of the geotechnical engineers, you always have to practice on it, like Allbile, Gent, Settle3D, Geo5, MicroStation, Excels, Python, SPSS, and all those different tools and skills. You have to be familiar with lab and field testing, and my last advice for you is always read and read and read. Keep updated in the field, keep reading the recent books and the literature and the articles, because articles are really shorter and easier to find. You can keep updated with the field of foundation and geotechnical engineering. This is the end of my webinar. I hope it was informative and helpful for you guys. And thank you all, and I'm open for any questions.
Thank you, sir. Hello.
Yes.
If any participants want to ask the questions, please raise your hand. Otherwise, we have the questions already. You have been asked before when you can do the registration. So Hamza sir, the persons who can raise your hands and give ask the questions. I have to just share the one screen. Okay, already the participants has been asked some questions. So if possible, you can share with them. These are the questions they have been asked. Okay, sir. Shivani has asked that about the construction process is wanted to know. Okay. For example, some others are asking which types of the footing is provided for the different soil conditions and how read the soil report, sir. If you can.
Sure.
Okay, sir.
Actually, as we have shown for about the construction process that we shown in the loop before reaching to the construction phases or construction steps, there are certain processings or phases has to be done before we reach the construction phase. We have to discuss with the owner, with the consultants, and we have to analyze the soil reports. We have to develop the soil report, the lab field testing, and then we can discuss with the structural and analyze the model between the structural engineer and the geotechnical engineer. Then only it will move to the construction. And the construction stage or the construction phases differs depend on the type of the foundation, the shallow foundation, the isolated or raft foundation, the micropiles or piles. Each type of foundation has different system in construction stage or construction phases, but all in all, they do agree in the conceptual part of it. Which type of foundation provided for different type of soil conditions? We have mentioned in our webinar that it depends on many factors. It depends on the geotechnical designer himself, or herself, the experience, and the soil profile, of course, and budget or the cost of the client or the owner. How to read the soil report? I think this is an important question, and it needs another even webinar or seminar to go through it, because how to adopt the design parameters from the soil model, which values we have to read or to focus on. These needs really detailed explanation, and I hope in different webinars.
Sir, one more questions. Okay, the participant is asked about the geotechnical aspect. Okay, which is affected to the foundations of the structures. Can you highlight about it?
Yes, actually, many of geotechnical parameters can affect the foundation of this of structure or the structure itself, as we can say. Because as we said that the soil structure interaction do affect the superstructure and the foundation. It is not independent. I know that many of structural engineers, they do analyze their superstructure in ETABS or structural models, and they do not focus on the foundation, and they design the foundation externally. But what is happening is that the foundation settlement and deformation, the foundation behavior, do affect the load distribution in the superstructure and the columns and the slabs and the beams. So you have to consider those soil structure interaction aspect in designing the foundation, as well as in the superstructure element. So, the soil deformation, the creep, the type of the soil, the groundwater table location, the depth, and the flexibility or rigidity of the foundation. All of those geotechnical parameters do affect the structure and the foundation of that structure.
Okay, sir, one more question from the participants. Okay, how we can be the use this Plaxis or maybe the FEM analysis in for ground improvement techniques, sir? Can you highlight it?
Yes, actually, there are many applications for Plaxis 3D, not only raft or shallow foundation or deep foundation. It can be used for soil improvement, like deep soil mixing, stone columns, rigid inclusions, jet grouting, and many ground freezing. Even people are using finite element and Plaxis 3D and mentioning Plaxis 3D or 2D, there are many literature and resources available freely, even from Bentley, about adopting this tool in ground improvement technique. So yeah, they can be used for sure.
Okay, sir. Kanu, can you unmute yourself and ask the questions directly? Kanu Bamania, one of the participants want to ask some questions, sir. Please.
Sure.
Kanu. Hello.
No question, sir.
You raise
No
your hand.
question,
That's why you raise your hand. That's why. That's it. Okay, sir. One more question I have to ask that, sir. Hamza, sir.
Yes.
Hello. What are the difference between when we use the more over the meshes and about the less meshes?
Actually,
one slides.
Yes. Actually, the mesh, the mesh dependency or the sensitivity of the mesh is one of the crucial topic in finite element model. You could say that one of the disadvantage of the finite element modeling is being mesh dependent. We have different tools, for example, the material point method or the discrete element modeling. They are not mesh dependent. They do deal or analyze the problem independent, almost independent of the mesh. But how to make sure that our mesh size or our mesh selection does not affect or does not make our analysis results or outputs wrong is by conducting a mesh sensitivity analysis. And I don't want to generalize this, but usually as finer as you go with the mesh, if you make the number of elements in the mesh more and more fine and more small elements, this means you are more accurate. But the problem with very fine and very small mesh element, it is the time consuming. It will consume a lot of time, especially for big and advanced models. And we want to reach a balance where we have a good results, but always a relatively short calculation time. How to do this is by doing sensitivity analysis, and we will see where the results start to be constant, the output starts to be constant, and we will select that particular size or type of the mesh.
Okay. Any another participants want to ask the questions? Hello.
And in any time, if you have any question, you can just email it to me. I would be happy to answer.
Sir, can you share your email address?
Sure, I will send it to the organizers, and anytime you can reach me, and I am happy to answer any questions.
Sir, one of our professors wanted to interact with you. So I welcome to Dr. Yogi sir.
It's been nice to have your presentation.
Thank you.
There is regarding slide number 23, regarding the factor of safety with respect to deformation. So yes. That deformation values that encountered, it is a realistic one, or it is a while doing factor of safety performing slope reduction, I mean SSR.
Yes.
Can you? Yes. So yeah. we might have a deformation value even though with the pile and sheet pile. So yes. It is around 1000 mm. So is it? I mean, realistic?
Yes. Or, yes. Yes, actually, when we are performing the soil structure or the soil strength reduction method SSR to determine the safety factor, those deformations are non-realistic. They are non-physical. We call them non-physical. So they mean nothing. It doesn't mean that the foundation system or the shoring system will or the sheet pile will deform by this amount of deformation. It's all because this is how it works. The SSR means that we are gradually reducing the shear strength parameter or the strength parameter of the whole system. If we can limit it only to the soil, so it will keep reducing the strength parameter of the soil till a constant failure occurs. Or if we add the structural element and model them as elastoblastic elements, it can reduce also beside the soil the structural element itself. And then it will keep reducing it till the failure occurs. But it doesn't mean that the foundation or the shoring system will deform by this amount. Those are non-physical deformation. What interests us in this chart or in this diagram is the factor of safety, the constant factor of safety. So this is our factor of safety of the system. And when we include the different structural element, or we consider the elastoblastic behavior of the whole elements in the system, this what we are after, this y-axis, actually, the factor of safety. But the deformation, you can consider it as calculation steps or calculation phases. It doesn't mean that the foundation or the system will deform by 1 meter or even just 10,000 millimeter, 10 meters. So yeah.
Yeah. I mean, have you gone through X pile in the sense, because in China it is famous one, but in Middle East,
actually we tried to import it from China for one of our projects, but we haven't. We went through the conceptually to adopt it in Middle East, but as you said, yeah, it is famous in China, but not anywhere in the world. I haven't seen it outside China, to be honest.
Yeah, some of the thing is just like a even triangular pile also. So I think the
Yes.
triangular is most famous. I think Indonesia and Vietnam, and particularly might be in stick to that region.
Yes.
So is does in Middle East or somewhere that kind of, I mean, you know,
Yes,
that different shape of pile, different shape of pile are being popular. So some, I mean,
rather than the circular and square piles, I haven't seen.
yeah, yeah. Okay, okay. Thank you, thank you. And once again, thank you very much for your presentation.
Thank you, thank you.
Hello, Darshan. Hello, Darshan. Thank you,
Yes,
sir.
sir.
Please, you may proceed.
Yes, sir. Is my voice audible?
Yes, your voice is audible.